Hey there, and welcome to a new channel review, and today's star will be the new Rigol DHO924 oscilloscope. This oscilloscope is part of the new wave of 12-bit oscilloscopes, where we can find the DHO800 and DHO900 devices series, and oh boy, this device is packed with features. It's not only about having the feature, but going the extra mile to have it really well done. So brace yourself and bear with me for a long video. It is a lot to cover, and I will not even be able to talk about the function generator that this model doesn't have. But it is an option that you can choose when buying yours. Or the logic analyzer. I don't have yet the probe to properly test it. But I covered everything else, and you have more than 22 to 25 chapters to watch. Other than the color, maximum analogic bandwidth, sampling rate, the logic analyzer, and a few technical details like the max memory depth. What I will show you today in the DHO924 is exactly what you can find in terms of the interface and features on the DHO800 oscilloscope series. This oscilloscope will be my new main oscilloscope for the channel, and I will use the available VESA mount to hold it in the support already installed on my workbench. But I'm getting ahead of myself. Bear with me and I will show you every feature of this device, and I will test it for you. It's now the time to let you know that this device was sent for review on a Rigol collaboration with the channel, almost free of charge, and no payment was made by Rigol to produce this video, and they will see it at the same time you will when it's published on YouTube. A big thank you is in order to Rigol for the collaboration with the channel, but not only. A big thanks is also due to you, my viewer. Yes, you that help the channel by using the affiliate access links on the screen or in the video description whenever you access AliExpress or Amazon for doing your purchases. You pay exactly the same, but only by the simple fact of using these links you'll become a channel sponsor and will help me to maintain the channel and keep producing these videos. Now, without further ado, let's get started with the key features. Allow me this small break to send kudos to this video sponsor, PCBWay. Being a leader in PCB fabrication, it is able to manufacture with very low price and in record time the PCBs for your project. Don't believe me? Just take a look. You get 10 PCBs double-sided for $5. It's hard to beat this. But that's not all. You can even create your project parts like custom case with their injection mold service or 3D printing, not to talk about their professional CNC machining service. It's a one-stop supplier for all your project needs, and if you use the code below on the screen, you will get a $5 discount on your first order. Okay, this seems really like we are opening gaming computer components. Very nice packed. Okay, let's open this. Okay, so we have the oscilloscope, a set of 4 test leads, the power cable, the power supply, a USB Type A to Type B cable, and finally a ground connector cable. So let's take the protection out, and ooh baby. Okay, as first impressions, again this is very compact, really small. Let me bring the ruler again, and we have also 26 centimeters by 16. Yeah, so this is exactly the same dimensions as the function generator. Yeah, exactly the same, as you can see. And in terms of light, exactly the same. Those units are very compact, very nice. We don't need space taken from the workbench, so we have a very compact unit. The buttons are in silicone, very nice to the touch. Okay, and we have clickable buttons also. 4 channels, logic analyzer, and a USB port. We have the normal reference output for probe calibration in the bottom. In the back, we have also the VESA mounts. Again, I will put this on a holder. We have the auxiliary out, an HDMI output, a USB Type B connection for connecting to the PC, a LAN port, and the USB Type-C connection. Also available is this connection for HERT. We have a special cable to connect directly to the HERT or to the ground, since we are powering this with USB Type-C and we don't have a connection for HERT that way. But as an advantage, this is also an isolated oscilloscope. Okay, we have the fit. It will give you this position. It will give you a nice angle for working. Okay, and on the bottom, nothing special. We just have this grid for ventilation, yeah, for the airflow. Okay, we have this small handle also on the top. It seems to have a very nice compact and resistant construction. Okay, on the top we have also more vent holes. That's it in terms of first impressions. Let's power this on and see it working. I have here the oscilloscope ready. Let me start by powering up. Yeah. While it powers up, let me talk a bit about what we have in terms of keys and everything else. So these 2 buttons are configurable. They are clickable also, and depending on the place of the menu that you are, they will have different functions, and they can have also specific functions that you can assign them. In here you have the vertical configuration, the vertical control with the channel control, and also the knob for changing the amplitude. Also math, reference, and logic analyzer functions. In this part you will have the record keys and also the time-based division control. Trigger functions in this part, and on the top the measure, cursor, and analyze functions to activate those features. We have a quick button that is configurable, and I will show you how to configure the functions on this button, and we can lock the touch using this key. On the right top corner you have the normal functions with single, auto, run, and also clear the configuration and everything else. On the bottom you have here on the right button the output for probe calibration, 4 channels, and a logic analyzer socket for connecting the probes, the digital 16 probes in here. We have also a USB socket, and I will use a dongle in this USB socket, a small dongle. Let me put it here. That will allow me, no shutdown, cancel. That will allow me to use a mouse, as you can see on the screen. It's a very cheap mouse in here. You can use also a keyboard or any other USB device that is supported by the Android system that powers this oscilloscope. I have everything that is needed to start showing you the functions. Let me start by showing you the screen. In terms of the screen, this screen works with Windows, and this window is the output signal. So right now let me power my function generator and do an auto. In here what we have is the sine wave currently. I don't know if you noticed, but you had the trigger level on the screen when I do an auto. This dotted line is the trigger level, and then you have the output signal. On the top you have here the run state indicator or label. Right now it's with TD, but you can have run, stop, wait, and auto. You have also the horizontal value in this part. This is also a menu. Let me show you. If you press it, it will open a window. I will show this in ahead. In this A part, you have the sample rate, the memory level, and this is the acquisition mode. Right now it's in normal. You have also in this the horizontal position. So this displays the horizontal position. Let me show you. If you change the horizontal position, the value will change there also. And we can do this with the mouse. It will be much easier. Okay, 0, it will be, okay, 0, it will be nice for now. And we have the trigger information. On yellow, it's the trigger channel. And you have also in this part the trigger level, trigger mode, and so on. This is a function menu that you can use with the mouse. For example, you can use like this, or if, oops, cancel, or if you want, since this is a touch screen, you can simply drag it to the desired option like this, okay? And on the top, that's what we have. We already spoke about the output window, so let me start in the bottom. And before that, we have here the result window. This window will allow you to see some results like the multimeter, the cursor's results, the frequency counter, and everything else. The results will show in this window that you can minimize like this. And since we are using Windows in this operating system of the oscilloscope, you have on the top here the hamburger menu for the Windows options. And on that Windows options, you have the type. Right now it's vector. If you want to, for example, activate the persistence, it's in here that you will activate it. Let me show you. I will start a sweep. Okay. We have the wave intensity. If I want to change the wave intensity for a lower intensity, it will be in here. Also, if we use the grids half or none, right now it is not so visible. Let me take the sweep off. Okay, and we have also a clear key. As you can see on the screen, I'm pressing the clear key to reset the image, and we can see the grid with a, well, half and full grid with all the divisions on the screen. We have also the grid brightness. You can see it changing, and the window transparency with full or none transparent. But even the none, it's not quite none. We can see what is on the back. But yeah, 50% seems good. Also the cursor brightness. I don't know what is this cursor, but I believe it should be the cursors that you can activate on the oscilloscope. If you want to see the scale or not, you can see that the scale is here and here, and this is very good, very informative, and it sees very well. The color grading, let me activate again the sweep, and you should have, I think, color grading over here somewhere. Yeah, it notices a bit, but yeah, okay. So color grading and the waveform freeze. In terms of windows, that's what we have for configuration of each window. Now that we talked about everything in this part on the top, let's go to the bottom. In the bottom, we have this function menu with the Rigol logo here, the channels, the digital channel information or activation, and the match channels, and we can activate also the sound by clicking here. Okay. Right now I will show you that we have a lot of functions that can be activated using this menu. I will show you these functions ahead in the video. There is a lot of things to show you, and if I don't categorize it or put it in chapters to make it easier to see this video, it will be quite confusing and will be all over the place. So there is a lot of things going on in here. For example, this one is the quick button configuration. We will talk about that in a bit. Upgrade, utility, restart and shutdown can be also done through here. And even the auto that has a button, we can do it here. But this allows us to, for example, to remotely control this device. That's pretty cool. Regarding the vertical and horizontal configuration of the oscilloscope. You can always use the keys or the knobs to do that, as traditionally you will do it. But wait, there is more. We can press here on the top in this option, for example, and we have the horizontal and acquisition options for the oscilloscope. Let's start with the acquisition. That can be normal, the average, the peak, or the ultra acquire, and I will show you how this will work and how this will be amazing, the ultra acquire. Also, the mem depth can be auto or can be manually selected up to 15 megas, and this depends a bit on the acquisition mode also, and yeah, auto is normally good. You can activate the XY here. If I activate the XY, the channel 2 will activate immediately, as you can see on the screen, since XY requires 2 channels. And we have another window with another options only for this window, that is the XY. And we can have a lot of windows in the screen. I will show you ahead. Let's go again to this acquire menu. It is possible also to activate the roll mode, the expand center left right trigger or user. The scale can be configured or you can enter it manually here. Also you have these buttons to change, like a quick shortcut for this, and activate the zoom function on the screen. And with the zoom function comes a few more options, like the scale. Okay, and let me show you in a bit. The zoom function will be here on the top, and changing here on the time division knob will give you a different signal and will show you, well, which area is covered with the zoom. Okay, let's go back. Let me take the zoom out. We can change also the horizontal position. You can see the cursor on the top. Let me show here on the screen. This cursor is moving, yeah, and you can do it in here also. Again, this can be done directly on the screen, but also in here, and you can activate the vernier. This is the horizontal screen options, where you have the time division, but you can also, let me exit this menu, activate it by clicking on the channel on the bottom. For example, 1 click activate the channel, 2 clicks activate the menu, 3 clicks deactivate everything. Okay, 1 click, 2 clicks. This is the menu for the vertical information, and this is quite good. You have this diagram of what happens in the oscilloscope with the options that you make, and I will show you when I'm selecting here the coupling and the units. But let me start from the top. You can select the channel that you are configuring just by changing here on the top this tab. Okay, so you can activate or deactivate the channel in here. Also, you can put define on or off. The scale of the signal, you have here the voltage for the scale. Oops. Dragging this, like your finger, you can drag this on the screen to change. It is always controllable by using the touch. And you can have also the offset. Let me see, you can change the position on the screen with the offset directly in here, or you can drag the signal up and down like this also. Again, you can do it with the finger or with the mouse. That's what I've done. In the bottom you have, well, you have here on the middle the probe selection. Right now it's 1 times. You can select 10 times, 100, 1000, whatever you need, it's in here. Okay, but then you have this schematic here that will change according to the options that you make. I will show you. So we have here the wattage, amperage, voltage and units. Okay, and we can select the coupling. Now I'm showing you with the camera, with the external camera. Take attention in this place. Now moving to the HDMI signal, and right now I have DC, but if I change this to AC, take a notice there, and this switch changed the value. Okay, this is so cool. because it gives you an idea of what happens when you change something. For example, if I change this to ground, take a notice in this switch where I have the cursor. Okay, I change this to ground and it changed here to connect to the ground. Now if I change to AC, this will connect again to the probe and this one will activate at the same time. Okay, very cool indeed. It's nothing special in terms of functionality, but in terms of learning and showing you how the process is very good. So you have also other options. I will talk about the trigger acquisition and measure a bit ahead in the video. Right now you can have the label on or off. You can see here the label channel 1, and you can even write something in the label name. For example, let's put BBBB in there, and you can see that the channel name now has BBBB in there. Let me take it out. If you have a keyboard connected by USB, you are able to do this on the keyboard. Okay, the channel invert, the bias option, and the bandwidth limit with off or the 20 mega. Also the channel to channel skew configuration is in here. So in this right side we have the trigger acquisition and measurements, but each of these options will have their own chapter in the video, so I will not pick up here for a matter of organization of the information, that it's a lot of information to pass to you. What I will show you now before going back to this menu is basically the digital functions. I don't have the LA probe, the logic analyzer probe, so it's impossible for me to show you this configuration right now. I will have a video in the future showing how the logic analyzer works, and I will show you this menu. Right now it's impossible, but it's possible to show you the math menu, and I will have a chapter in this video for the math menu, but I can show you already how the windows work. As you can see, this can have a lot of windows. Each of the windows has this burger menu in here, and you can select for each of the windows the options that you want to run in it. So another cool thing is that you can put the windows as you want. You can distribute the windows on the screen as you want and have several options for it. Okay, you don't have properly a limit. I think it's in here. For example, if you want the XY, also you can have a lot of information on this oscilloscope, and everything works really well. And regarding what you have on the screen and the main functions, it's only missing this menu where you can activate the measurements, the histogram, the cursors, windows, math functions that you saw already, XY, the reference, signal, counter, multimeter, the decode menu, the pass and fail, the search, and this is not Google search. This is something different. I will show you. Record, auto, display, clear. For example, you can clear the screen and everything with this option and do the quick configuration, access the storage, the upgrade functions, the utility. Let's go to the utility, that is also base configuration. The utility is very similar to other oscilloscopes. You have the I/O configuration. Right now I don't have this connected to the network. I will have with DHCP, but you can have also auto IP and static IP. Auto IP is on DHCP, obviously. You have here the network configuration if you are using MDNS on the host name. You have also the setup for several functions like load last. The first of all, it's the language. We have several in here. Then you have the load last, default last, the power stats, switch off or switch on, beeper, trigger out or pass fail on the X output, input lock if it is on off, expand ground to center, and fine and zoom operations. It will be fine or zoom according to this option. The about with all that is with the model, the serial number, the firmware version, the hardware, and everything is in here. We have the web control. I love the web control. It's really cool. the open source acknowledgements, the auto config, peak to peak, live channel, overlay and keep coupling. You can activate or deactivate. Self calibration, self-explanatory also. Options that are activated. I have everything activated in this oscilloscope. The quick configuration that you can go from here also. So this is the quick configuration, and this configuration is for this key, the quick on the keyboard. And you can have, when you press that key, it can save an image, save a waveform, and I don't know if you noticed, but the options on the bottom change. Right now it's saving PNG. It can save BMP or JPEG. Invert the image, and the color can be color or gray. We can save a waveform. We can do a save setup, activate all measurements, and you can select which channel will activate all measurements. Stats reset, activate the record, or a save group, and we'll save several stuff at the same time. Okay, right now I will leave with the save image, seems okay. And finally you have the key tests, the touch test, screen test and board test. For example, for the screen test, it will show you different colors to see if there is dead pixels or something like that. Okay, the board test will show you the temperature, the voltage, and other things like that. And yeah, basically that's it. Quick, yeah, self-check. You have also the touch test. In the key test you can press all the keys or certain zones of the screen to see if it's working correctly. As you can see, we can see if everything is working correctly in here. Okay, exit. This display is basically the same thing that you have in this hamburger option. Okay, so mostly some of these options are available on the keyboard or directly on the screen. The upgrades, it will search for the USB for the upgrade file. And one cool thing, you have always the user manual here available for consultation. You can go and zoom and do whatever you want. As you can see, this is like using a tablet. You can use it to navigate, and I will leave now. But it's very cool to have the complete user manual in here. About this clear option, you have also in the keyboard a clear option button. It will clear the screen. For example, if you have on persistence, if it left some noise in the screen, you can clear the screen with this. And you have also the restore option. When you press it, it will bring everything to the default options. It will restore the default options. Okay, regarding this functions menu, I'm only missing to show you the storage. You can save. When you press save, it will be save image, save wave, or save the setup. Also, it can be, as I've shown you in the quick button, you can select well, several options on the save, invert. The file name can be also specified by you. Right now is Rigol EDS. And the path can be local disk, but you can select other paths if you have that configured. You have also the option to load a file from the system, and finally you can do the upgrade. Let's go to the disk and we can see what is saved in the disk. I have already some options in here. For example, I can do a rename if I want, delete, cut it and copy to other place. We have several options available in that. This is pretty cool. We can create folders and security clear. I don't know if I want to do this right now, but basically the name says clear, so it should clear something. Okay, going back or closing this, this is the storage menu. In this vertical options menu, the first submenu that I would like to talk about is the trigger. And regarding also the trigger, we have here a lot of options. Let's start with the type. We have 17, if I'm not wrong, types. like edge, pull, slope, video pattern, duration, and some are here, and in the end RS232, I2C, SPI, CAN and lean. So as you can see, you have a lot of options for trigger. You can also force the trigger, have the sweep in auto, normal or single, and select the coupling as DC, AC, LFR or HFR. And below the source, that can be one of the 4 channels available, you have the slope that can be rising, falling or either. And for that you have animation that can show you here what is the impact of your choices. So you have here the diagram for that. Also the level of the trigger, right now it's a 50%. The hold off, that is at 8 nanoseconds, and for last you have the noise reject. Back to the vertical options menu, we have the acquisition submenu. If you enter the acquisition submenu, that can be also accessed through this option, the H option on the top. You have different types of acquisition. You have the normal and the average. You can see that the signal changes a bit here in the screen. And again, you have the peak. You can see that the signal is a bit larger. And for the last, you have the ultra acquire. And this ultra acquire is something really cool. Let me show you. For example, you have the display frame. That's the number of frames that you want to display in this acquisition method. And the time. Right now it's 1 second. And you can have it adjacent, so it will show you the signals one by side of the other. I will now start the sweep, so you can take a look. It's a bit hard to understand what is going on here, but the signals are being copied one to the side of the other. So this is not continuous. You can see here in this place, you can see that is not connected one to the other. Let me change the time division. No, yeah. So in this, whoa. Okay. So as you can see in here, the signal is adjacent one to the other. You can have several modes in this. You have the adjacent, the overlay. Okay, it will show you the different signals overlaying one of each other. And then you have the waterfall. We can change a bit this to 0.5 seconds to be faster. Okay. So let's do again the overlay. And right now it is sweeping. Let's try without the sweep. So without the sweep, you will not see any changes. Okay. You have to have some animation to understand what is going on. And then you have the waterfall. In the waterfall, we don't need the animation, but you can check what is going on. And you can have 25 frames as you can have 250. Let me put here 250. Okay. And you can see all the sine waves in a waterfall, and it's replacing the sine waves as we go. Okay. Let me take this out of the screen. You can see the movement. It's very, very smooth, but you can see the movement is going here, updating the screen. Okay, other than the waterfall, you can have also the perspective. This is a really cool one also. Let me pass this to 50. It will be more usable. Okay. So you have the perspective also. And for last, we have the mosaic. The mosaic, I will need to show you this. It seems that it's the same line over and over again, but if I activate the sweep, take a notice that you can see that every division has a different signal that is being recorded. So it creates a mosaic of signals in the screen. This is so cool. Still in the vertical options menu, we have another submenu called measure. For this measure, that can be accessed also through this option. It's the first option on the start menu. As you can see, you click on this logo and it is the first option, and you have it also on the top on the function bar menu in here. So you can access it through several places. And for the measurements, in terms of vertical measurements, you can select the channel, the source A, between the 4 analogical channels and the 4 matte channels available. And you can select also what is the values that you would like to see. And you can see, as I select, for example, the V average also, it will appear here in the result window. And we can put anything that we want in here. Okay, now some horizontal measurements, like let's see what we have in here. That is cycle frequency will be a nice one, and periods also. Okay, the rise time, it will be also need to know. And we still have a few more, that is delay, the phase, and with some calculations. And in this other menu, you can have source A and source B as variables for these options that you have here. Okay, going back to the horizontal, and one thing cool is that you can select channel 2, for example, and you can have again the same options. In the bottom, it will appear for channel 2, and you have everything in here. For this, you can expand. For example, the VPP of the channel 1, you have the current with 5 volts, the average, the max, the minimum, deviation, and the count. Okay, and for each of these measurements, you can expand to show it all. Okay, if you want, there is also, if you select the measurement, you have several options. For example, the indicator, it's like cursors. It will show you the VPP with the indicator. You have settings. For the settings, you can have a threshold, an indicator that is on or off. You can also configure it here. The percentage or absolute, okay. You can see that it's changing according to what we want. The histogram, that's a cool one also. Let me show you. Okay, it will show you the measure histogram of the voltage peak to peak. For example, let me take this out, it's just for showing. Okay. And you can also show the statistics, and for that you just, it's the same thing of clicking this arrow. Let's see, I will take the mouse there, and as you can see now it's open. So this is the statistics. You have the count, okay, that you can change, and you can reset the statistics also here. The source channel for this measurement, and the amp method if it is auto or manual. Let's see what is the options in manual. We have histogram or max min, okay, and the base histogram or max min. We can remove this from the menu, and it can be done there, or it can be done here, and you can remove all the measurements in here. Okay, let's take it out. There is also an option to show all the measurements available. For that, we can come here to Windows and select on the bottom all measure, and then add. This will create a new window. Let me take this out of the screen. That will have all the measurements available to you in this table. Okay, it is a window of measurements only. And again, as usual, you still have the chance to change the parameters of the measurements. So this is pretty cool. And if you don't want to show these anymore, just press the cross in the top right corner and the window will close. I already shown that you can have a histogram in the measurements, but you can have also one in the main screen. For that, you have this menu that can select the channel, if it is enabled or not, the direction, if it is horizontal or vertical, the height, in this case 2 divisions, left limit, right limit, top limit, and bottom limit. So let's activate this and see what we have in here. what we can see already is that what is inside this window, that when you press it, open this, is where the histogram will evaluate the signal. Okay, you can see it here. Let me put this working as a sweep. Let me change the signal, and yeah, this will change also with the signal. In the bottom you have the histogram itself. On the right side, on the results column, you have also the statistics for this histogram. Okay, another function, it might be cool to use it. And if you want to change anything, just select this rectangle and it will allow you to open again this menu and disable the histogram. So this is another function that is pretty cool. You can reset the settings in here or close. One of the most useful functions in the oscilloscope is the cursors. Just like the measurement that has a special key, you have also in the keyboard a special key for the cursor. If you press it, you will have on the screen the different cursors that you can use. And using the mouse, you can position the cursor in the place that you think it will be best for measurement, like this. Just pick up the line and it will be very easy to position the cursor. Again, this can be done also with the hand. Let me try. Okay, you can see it's easier with the mouse, but you can do it also with the hand. Okay, so after positioning all this, you have here the deltas and the values are registered on while using these cursors. This can be activated also using this menu, this start menu with the cursors option. Okay, or deactivated in this case because it was already active. And again, if you press here in this option and do settings, you will have for the cursors a set of options that you can use. You have the manual, the track, also the XY if you are in XY mode, the channel for the AX source, the channel for BX source, if you are tracking Y or X, and if the AX BX is on or off. Okay, you have also a few more settings for AX and BX in terms of the time division. Okay, this is the options that you have for the cursors. You can press here to remove it. To show you the math functions, I have here a color graded sine wave already in the screen. And the math functions can be activated through here, through the button on the keypad, on the keyboard here, or using the menu with this option, the math. Let's open it. It's the same that pressing here. For example, you can create a channel directly in here. And right now for the first channel, we have the exponential operator. We are sourcing on channel 1 with the scale. We can change the scale for the signal. Can invert the signal. Also activate the label if you want. Expand to ground or center. Let me see the auto setting if you did some calculations. And also for this window, we can have the grids with full, half or none. This is a per window configuration and you can always customize to your needs. And this is the matte one. We can have up to 4 matte signals. Let's activate the second signal, and for the second signal, we have F50, but let's do A plus B. Right now I have a modulated signal on the second channel of my function generator. So for example, if we do A plus B, this should be an interesting value. It's not doing nothing because the source will be channel B. Format 2, yeah. And you can see that right now we have here some animation in this channel. Well, you have a lot of functions in terms of operators. That's something that it's always good to know. We have the normal functions, A plus B, minus B, A minus B, A multiply by B, or divide A divide by B. FFT and a lot more functions that are not so common in the entry line oscilloscope. So this is pretty cool in these terms. Okay, so for example, we have the exponential. I think we have already in here. You can see which function or which operator you are using. In this one is channel 2 and channel 1. Let me just demodulate the signal. Yeah, so right now we have the signal steady, and we have channel 2 plus channel 1, or the exponential of channel 1, and this is pretty cool. Something else that you can have is FFT, obviously, and low pass, high pass, band pass, and a lot more. So again, we have 4 MET channels. You can activate all of these channels. You just come here and activate it, and it will arrange itself on the screen as I've shown you before. Or you can even do as you want, divide it as you want in the screen. Let's see, like this. And you can have a lot of information in this screen. Let me take 2 of the channels out. Okay, 1 off, and we still have this information that will appear when you click in here. Okay, let's disable the channel and the 4th channel also. Okay, so one of the things that I want to show you next is the FFT. So for the FFT, let's put FFT on channel 1, or no, let's keep it exponential, and for channel 2 I want to use the FFT. Okay, we immediately have several options in this. The scale, the window, if it's Hanning, we can have it rectangle, black man, Hamming, flat top and triangle. For now I will keep it Hanning. And auto setting, if you want the units to be dBm or dBV or VRMS. Okay, you can see that immediately change on the window. You have the span, the offset, if you want color grading on it. Okay, and again the same options to configure the window. Okay, so we have this already in place. We have here the FFT. Let me modulate the channel 1, that's the source for this. Okay, let me put this one on the top, it will be better. And what I will do now is change the time division of channel 1, and you should start to see some changes here. Okay, I don't think color grading will be a good idea for this. Let me take off, and yeah, it will be nice to know that it's available. And you have here the harmonics, and if you notice, this looks much like a spectrum analyzer. You have the dBV here, the frequency, and in the middle the harmonics. And this function normally is not seen in these oscilloscopes with such a high quality. I can even take this out to have a better window, or even transform the window completely in a spectrum analyzer. So how cool is this? Really, I am impressed with this oscilloscope. I think it's amazing, the functions they packed in such a small device. I have in the screen 2 sine waves. Those 2 sine waves will be to test the XY mode. Let me now came here to the channels. I believe it's on acquisition. Let's see it. Yes, XY mode. So for XY mode, I will take from the screen the other 2. I will start by changing a bit the frequency on the function generator. Let me see if I can. Okay, here we have it. Let me try to edit this. Not okay, and we can speed up this a little. Yeah. Also, let's try to put this at 3 volts so the signal will be lower. Okay. Okay, we have a shorter circle in the screen. And now, again, let me increase the signal. Okay, you can see that the rendering is perfect. We have here really perfect rendering. I can even increase here again the speed. Let me show you. Yeah, we have a perfect render. Nothing to talk about. So now I can show you also that for this we have some options. We can select the source for X or the source for Y from the 4 channels available. And we have some advanced settings that I'm not being able to personalize. Not sure why. Let me close the signal. Yeah, I don't know why I'm not being able to personalize these settings, but you get the idea. You have here the persistence time, persistence in frame, wave height, wave intensity, auto compression. So yeah, let me bring this again, some more animation, some more crowns in here. So this is very nice to see. The rendering, it's awesome. It's a test. It's another cool function that you have it. Something else that is also present in the screen is the voltage in both coordinates. Another function that I want to show you is the reference. The reference, so you come here to the menu and you have this option, reference. Okay, this is a pretty cool option. Let me use the mouse to show you. You have 10 possible different references that you can select from the 4 analogic channels or 4 mathematical channels, and you can also save it in the oscilloscope memory. You can import it back and you can choose a color from gray, green, light blue, red or orange to save it or to display it on the screen with a text. Let me see if I can here insert something like, okay, all caps, Hugo. Okay, this will be my reference label. I will create a label on and I will save this on ref1. Okay, as you can see, we have the scale, the offset of the reference. We can export it. Okay, so you can export this to the local disk. You have several formats to export this. So let's put here in Rigol, let's put here something like dash or okay, Hugo. And we have the file name and let's save it on the local disk. It's saving our reference, okay? And if I want to import it, I can now use it. I will check on the local disk. It seems that it didn't find anything on the local disk. Yeah, it's here. Okay, and load. Whoa, what is going on? Maybe I'm doing something wrong. So it's a ref format. We have the local disk. Select this one. Okay. I was doing it wrong. It's not too intuitive, but we do have here the checkbox. So, okay, it's selected and then load, operation success. Awesome. So let's take this. I loaded my reference that was saved with orange. And let's see what happens in here. I have here the reference signal that I can use, for example, to see if everything is okay. You can have a device that creates a reference signal, and then you can save it and import it to check on another device if the signal is equivalent or even equal. So as you can see, this is pretty cool. And for example, instead of Hugo, this can be like the signal on the DHO922 Pro, the sine wave, and the same sine wave with the same frequency on the one that I have here. And I can check if the signals will be equal for different devices. This is a very useful tool. I did a simple example just to show you how this works. If you want to activate this, just press on R1 and you have the reference. And you can have several references in here. For example, if I change the amplitude of my signal, like this. Let's go again to, I want to select reference to, I want to save to reference, okay, and now I have reference to in here. It's in orange, but oh no, this one is red, I think. Let me check. No, this one is red, but I can change it for light blue, for example. Okay, so I have here the second reference in light blue. If I change my amplitude of the signal like this, I can check this on reference 1, that's Hugo. Okay, and if I change the amplitude again, I can check it with reference 2. So pretty useful, pretty awesome. You can have 10 references, you can label it with the names that you need, and you can save it and import it to later usage. Now, on the keys available for you on the oscilloscope, you have this one that is analysis. And for the analysis, you have several options like the DVM, the counter, the record, and the pass and fail. This is analysis functions that you have here available for you. I will start with DVM. DVM will create here on the screen, well, a multimeter. Right now I put my function generator outputting a DC channel, a DC signal with 5 volts, so it's detecting 5.026. I think this is pretty accurate. I can change, let me see if I can do this manually. Now I'm changing like 4.9, 4.8, yeah, let me take to 4 volts, 4.0, I will change it to 1 volt, okay, and below this what we have, let me see, 500 millivolts, still pretty accurate, 508. Let me take this to 100 millivolts, 108 again. So what else? 50 millivolts, 30, 10 millivolts. Let's see if we can identify 10 millivolts. It takes a while to get there, but this is not a multimeter. Okay, in 10 millivolts we have a 5 millivolts difference. We can also use some settings in this. Right now I'm with DC. We have AC RMS and AC plus DC RMS. We can have a beeper that will beep when it's doing the counting, and it will beep within in limits or out of limits. Okay, let's activate the beep again. So it is within limits and it will not beep, but let's see if I put the upper limit in 1 volt and the lower in 0 volts. I will change, let's put the beeper on. I will change the values on my function generator to, let's see, 2 volts. And it is beeping because it's out of the 1 volt limit. I will pass to 1.2 and let me, right now it's 930 and it stopped beeping. So it's pretty good. It's a nice function to have. And yeah, that's it. So on the screen you can see a square wave, and the purpose of this square wave is to show you the decode function. I will not try to see the decode function in real protocols because this video is too long and I don't have the time to prepare something for that. But I will be able to show you the decode function working anyway. So the first thing that I will do, for example, is to show you what it will happen if in a bus type like parallel you activate the bus status on channel 1, and for that you can have a clock or not, the threshold, the endian if it is inverted or normal, and the polarity if it is negative or positive, and the width, the bits. The format, right now it's in X, but can be decimal, binary or ASCII. You can have the label on as always, and a event table. I will activate the event table also so you can see it, and we'll take this out of the screen. So as you can see, when it is down it's 1, when it's up it's 0, and this happens because I activated the decode with negative. If it's positive it will change. Right now it's the normal one, it's with 1 when it's activated and 0 when it's not. You have also in the screen the index of the decodes, the data table, so everything can be stored in here. Okay, I will take this out of the screen now. And for example, if we decide to change to another protocol, we have it right now in parallel, but we can have it, for example, in RS232. Let's see what we can have in. We will receive on channel 1, we will transmit on channel 2. Okay, or let me change it, channel 2 for example. And we have also the thresholds, the positive in and negative in polarity. I will set up a baud rate of 250 kilobits, data 8 bits, LSB, X on, and event table also on again. As you can see, we have errors. Of course we have errors because this is not really a serial transmission, but anyway, you can see that he captures the things. We have on the screen the values that he identifies. Okay, I will activate this again, decode. Let's change this to channel 2, channel 1, channel 1. Let's see what we have. Okay, so we have in here the decoded signals. Okay, it seems that he, like this, he already identifies some data, like the letter N, and only with this transmission you can see what he identifies in here. So again, if we go to here, we can, I don't know what we can test also. IC2, for example, let's see what he has. Right, read A1, right. You can see it working in terms of the decoded signal. Okay, we have it here. Yeah, and B1 is the decoded signal. We can even pull it out of the way, I believe. Let me see. Yeah, we can put it here and you can change this. So you will be able to use this decoder even without the logic analyzer working. You can, with the normal probes, try to decode the signals. SPI, you can also work with this, with SPI. With SPI you have also the slope rising or falling, the modes, timeout, CS, polarity again, Indian, CS, you have the clock, the meso and the MOSI. So the CS also in the channel 3, and yeah, you can configure all of this to be able to decode the signal, and even can. Okay, and lean. Okay, so we have parity bit, with, without, the version, the baud rate that we will use, the source channel, and the format. This is more or less common to all the protocols, but we don't have anything in here because we are not able to decode. This is not a valid signal. But anyway, I think that you can have the idea of how good it is this for decoding also. If you want to test a signal for values or outliers, you can use the pass-fail function. This function is very cool also. You can set up like this, you enable the pass function, and you have the divisions in here. Okay, I will not change it. Oops. You have the vertical divisions, the Y, and the horizontal divisions, the X, that you can define. And then you can also have, and let me show you with the mouse, I will put this window a bit over. You can have several actions when this happens. So when the output event occurs, it can be fail or pass, and what will happen in case of error, it will stop, it will beep, and it will create a screenshot if you want automatically. Also, the polarity can be positive or negative, and the pulse right now it's in 1 microsecond. This is easy to operate. We don't have any values, as you can see in the result window. When I put the operate, it stopped, and it says that one waveform failed. Okay, so the action that I had here was stopped. But if I take this out, let's press here, do a reset stats. We are at 0, and let's go again to, I think that we can do here on settings. We have the window again. I will do operate, and right now it's saying that it's failing, but since I don't have the stop in here, or the beep, let's do a beep also. Okay, you listened. It will beep and stop. We can also take a screenshot, but it's able to just record the fails or the passes, or if you want, you can stop and do this action. You can define obviously the division size, for example, run it again. It still has one waveform failing, and if we go here, you can see, well, what is defined for the pass and fail. And yeah, basically that's it. You can use this to detect if the signal is within several parameters. We can create this, as you can see on the screen. Okay, it shows you what will be. Let's do a reset stats, and again settings, and right now it's passing because the signal is within the limits. Okay, so I will increase the signal directly on the function generator, and it should fail right now. Okay, so I increase the amplitude of the signal on the function generator, and as you can see, when it reached the threshold, it stopped with a failure. So another cool feature, and yeah, that's it in terms of pass-fail system. You can see on the screen already a sweep of a sine wave, and this is because I will now show you the record function. For that, we can activate from here. As usual, you should have it on the top also, or not, I don't know, the code, yeah, it's here on the top also, or you can come to analysis and the record. So you can activate this in several places. Right now it's on the record, and to record what is going on, I will start by pressing here when it says record. As you can see, the frames are being saved in the memory. Is saving the signal that is being generated, and I will not take all the frames. Right now we are with 300 of 960. Let's get to 400, and that should be enough. It's almost half. And after this is saved, you have the minimize. Okay, but you can see it in here. You can move. Let me show you. You can move manually the frames. Okay, and you can move frame by frame what you saved. So this is another win for this oscilloscope. You have a great Among Us control on what you record. You can see here what is the frame that you are. The interval, it's right now 100 milliseconds. You can go to the first, to the last frame, or you just can play it normally as it was. So this is the record function that you can save the signals for later analysis. The thing that I don't see here is saving this to disk and being able to load it from the disk. But anyway, it seems very nice, a very good feature to have in here. Let's see what this button does. It's reverse. It shows in reverse, and this shows forward. Yeah, while playing it. You can set up here the interval, the beeper, and everything else. Okay, so this is the record function. Another way of controlling what you have in memory is navigating here on the memory depth. Let's do a run stop, and you can see the memory using this button, or this knob to be more precise. You can see the position in memory. But this oscilloscope has other functions for that, and you have here the navigate button that will open this menu, and where you can see by time, by search event, and you can see the edge or the pulse for search, and this opens a lot more options in the oscilloscope. I will not go through everything in here because you have a lot to configure, but you can configure, for example, in terms of searching for edge or a pulse, if it is rising, falling, or either the slope, the threshold, markable, to trigger. So you have a lot of functions here. And let's go to time again. I don't know, frame segment, it's not available, but you can see, for example, you can do like a play of the memory. You are not being able to see it now because this is in zoom. I didn't put this in zoom. Let me take this out of, it's on here, I believe, yeah, it's here. Let's take this out of the zoom and go back to the menu. Okay, operation disabled, we are in stop. I want to navigate, yeah, okay. Going back, and you are able to see in play the signal. You see it here on the top that we reach the end. I'm gonna go back to the start. No, it's on this one again, and play again, and he's moving. You can always move with the mouse or with the fingers the signal, but this navigate allow you to do it frame by frame, okay, in the memory, or just do a play of the signal that you have. Okay, so now I'm going to assemble, well, not assemble, mount this on the VESA mount. With the VESA mount it came these screws. They are a little big for what I would like, but I already use it here on my function generator without any issue. So it will support these kind of screws in terms of length. So let's start. It's a bit hard, the first screws, but then it will get better. Let's see if I can mount this. So let me connect now the HDMI. I want to... So I will do the cable management after. Let me just... Okay, so here we have it. Side by side. I will then level it up so they will be at the same height. And also I will do the cable management after, but this is where they all live from now on. And I want to use a holder like this to put the power supply on the back of this shelf, but I don't want to put this is a very strong glue. I don't want to put this glue on the power supply, so I will create a 3D print that will have a holder, and that will happen after. But right now this is mounted. Let's take this opportunity and power it on. Okay, VESA mount is done. One of the last things that I have here to show you, it was more or less covered already in the rest of the review, but it's this Windows option. Okay, so the Windows option allow you to create windows from this menu, It's a shortcut for the XY or the mat, the measurements or all measurements or the decode. And you can configure it in here with already a shortcut for options. Okay, and for XY we even have the source of Z. So we can have another channel to not only rotate the object or the figure in the screen, but even give another level of rotation with the Z. We have the mat that can be configured also from here. The measurements, this is the table of measurements. Let's add that one. Also, let's go again to Windows. We can put everything in the screen. That's pretty cool. The decode also, let's add a window for decode with the values. And what else do we have here? We can have a matte window, yeah, with this. And again, we can add windows. During the recording of this video, I was using always the HDMI output that I was recording. You can see here my setup of recording, and on the right side you have the HDMI output being recorded directly to my PC, but also I have a screen on the side, a 24 inches screen, where I was seeing everything that I was talking about. And that was very comfortable for me. I don't know, this is an experiment. I don't know if in terms of you as a viewer, the experience of seeing the oscilloscope screen will be good. So let me know on the comments about it. But it is really good to understand everything that is going on the screen. You can see here the mouse moving, and to make all this happen at the same time, I just use my Elgato HD60 Plus capture card. It has an input and output, and allow me to do this. You can do exactly the same if you want to also capture. And I've shown that also on my DHO900 Pro function generator. You can have the same effect using a HDMI splitter. It costs like $5 to $10 or euros. It's really cheap, and a cheap capture card like $10 also. So you can do the same with a very low budget equipment. But this is a very nice function, and the screen that you have on the monitor or the image is HD 1080p. So it's a very good image you can have in this screen to work with the oscilloscope. Well, that's it in terms of HDMI output. I hope that is something that you like, and let's continue. Another function that is available on Alice's, that is the last one that I will show you, it's the counter that I didn't show before. So the counter will be able to show you the frequency that you have on the channel that you are analyzing. Let me take this out of the screen. And you have also several configuration possible in here. You can measure the frequency, the period, okay, so, and totalize, okay, the hits. So it's the kilohertz that is reaching the oscilloscope. We can clear the count, select the channel that is being analyzed, and yeah, basically it's and we can have also statistics, so you can see the max, the minimum frequency, and the average. This is very stable from this function generator at this speed to the oscilloscope. You have the period also with the stats, but the totalize should have different values. Well, totalize doesn't have stats, so we cannot see that. That's a pity. Okay, the resolution also, you are able to see it here that you want, and remove the counter from the screen if you want also. I almost forgot to talk about this. It was really in the end that I remembered that I didn't talk about the search. Okay, so what we have here in terms of search. The search is well, a feature that will allow you to locate events on the signal. For example, you can locate on the channels of your selection if it is rising, falling, or either. This on the edge type, And you can have also the pulse type where you can set the polarity, and you can set also when that event will happen, if it is bigger than, lesser than, and different than the threshold. And you have also the lower end. You can have on this also a mark table, import from trigger, export to trigger, and save the events in the disk as a CSV file. Okay, so other than this, you can also navigate on what is saved. I will go back again to search, and let's try to have an event like a edge event, and I will say either, and you can see already that for the settings of the threshold of 99 millivolts, we have two events, one at 8.98 nanoseconds and the other at 37.4 nanoseconds. So this happens in a rising edge, and the other one happens in a falling edge. Okay, this is also a cool feature if you want to analyze or search for a certain event on your signal. And yeah, I think that we can wrap up now. On the screen you have already my Rigol DHO924 mounted on the VESA support. It is really cool for the organization of the workbench. It's something that I was waiting to do for a long time. And you have already in the screen two square waves perfectly aligned, and you have the output below the device on the screen, so you can check everything that is going on. And for these two square waves, let me show you, we have a frequency of 1 kilohertz right now. So what I will do now is change this to sine wave and copy the channel. And one cool thing that it will be cool to have, and I'm not saying that it doesn't have, but at least I was not able to find, is the synchronization between channel 1 and channel 2, for example, to replicate everything you have in terms of parameters on channel 1 to channel 2. You can do a copy, like I just did, okay? But if it is in real time, it will be much cooler. So what we have now on the screen, it's two sine waves. I can align them, okay? So they are aligned. And what I will do right now is pass this to 1 megahertz sine wave. Okay, let's copy again. Let's auto. Okay, so we have two sine waves on the screen. Align, you cannot even see the sine wave below, but it's here. Let's see it. Okay, so they are completely aligned. This is really cool in 1 megahertz. Okay, so what will happen now is I will pass this directly to 100 megahertz. Let's not waste time. We want to see how this works in real bandwidth. Okay. I forgot to copy. My bad. Okay. And in 100 megahertz we have two sine waves, two perfect sine waves that not even show the difference. This is really good. Okay. What I will do now again is upgrade this to 150 megahertz sine wave. Okay, a copy again. And let's see if they can align. And right now they are not being able to align. That's pity. But we are already at 150 megahertz. And the maximum is 200 megahertz. That I will go there now. But even so, the quality of the signal is very good, very stable. It's amazing, the quality of this. Again, align, and again, the signal is pretty good. Let me open, okay, a bit. This is at 2 nanoseconds per second right now. So we are with the maximum time-based zoom that we can do. And yeah, I don't see anything to complain from this. We are putting the maximum on the function generator, still having good sine waves on the screen, and the Rigol doesn't even sweat with this. So yeah, this is a very good. I cannot expect anything more than this. Of course, if I can go up to 250 will be nice. And I'm missing something that I always do when seeing the function generator. So this shouldn't be below. We are with 1 volt VPP. So what I want now is measures and the VPP measurement of this. So with 1 volt VPP, again, this doesn't even sweat. We are with a signal of 1 volt precisely. I believe that if we go to 250 megahertz, it will drop from the 1 volt, but at this moment, it's not even having anything wrong with it. Okay, so I will keep the VPP on the screen, and let's change these to square waves. In terms of square waves, it will drop immediately to 60 megahertz, I believe. Yeah, that's what happened. And I will do a copy channel. Okay, so we have 2 channels with 60 megahertz. Let's do an auto. Still no drop in the VPP of the channel 1. Let's add also channel 2 to this. Okay, I want also the VPP of channel 2. And we have a little difference, but still good. Okay. That's very nice. The signal, it's really nice. The quality of the signal. Well, the quality of the square wave, it's debatable, but let's go halfway. 30 megahertz. Again, copy channel. Okay, it's a bit better, like 10 megahertz square wave. Let me do it auto again. Okay, we are starting to see here a square wave with corners and everything else. Let me just do like this. Yeah. So at 10 megahertz, it starts to look like a square wave. In terms of the VPP, I don't have anything to point out in there. It's really stable, and I truly believe that this is the real VPP of the signal. And again, let's do a 1 megahertz square wave. Oops. And auto again. So a perfect square wave. We still have oscillation in the corner, but nothing serious at 1 megahertz. What else do we have in here? But 1 megahertz, we have already a drop in the VPP. Really? Let's do like 500 kilohertz. Okay, copy. 500 kilohertz is below 1 volt. Is this because of the sampling of the signal? That's weird. Okay, but we have a perfect square wave there. Okay, let's do 100 kilohertz. Copy. No, we are back again to 1 volt. Yeah. Okay, but to be honest, I believe in these values. It's not the case sometimes with other devices, but in this one, I don't have any reason to complain. Okay, right now we have 1 megahertz square waves, and let's try with ramp. Okay, copy, channel 2. We should have 2 ramps, 2 perfect ramps. And what else do we have in here? Like pulse, a ramp and a pulse, and arbitrary. This is a SEG signal and a ramp. We can do 2 SEG signals. Okay. And we can even go to arbitrary. Let me see what we can show in here. Come on. like an engine. I don't know much about cars or mechanical engineering, but let's see, for example, a Chevy Chev to signal. Okay, let's copy channel 2 and align them. Okay, they are aligned, as you can see. Just one more to see, like medical. I already showed, yeah, the cardiac ECG diagram, and 3-arm engine. I think we have here also voice. Yeah, let's see the voice channel, copy, and auto. So this is a voice signal right now at 1 megahertz. And okay, one more and we are done. Not this channel engine. We have also a TV signal in here. Okay, this should be a TV signal. Let me change the time base at 1 megahertz. Obviously the TV doesn't work at this bandwidth, but yeah. Okay, in terms of bandwidth test and different signals, that's it. Let's move on. Okay, so let's talk a bit now about the PC control of this device. I already connected here on my oscilloscope both USB cable to the PC and also the Ethernet cable, so we can control it by web. If you come here to the network status, we can see already that he has, and I'm already on that page, it has an IP that was assigned. That can be also seen in the utility menu. We have on the screen, let me check, we have on the screen the IP and all other connections available. It's obviously that is connected because I'm on a web interface, but it will show you also on the oscilloscope the connected button on green, not button, the connected word on green. Let me take this out of the screen. And in the PC, let's see, we have also the web control. This is a remote control, much like the HDMI or the drag functions. With the mouse you can control everything. So what I just did previously to open the utility, you can do it like this, okay? Or remotely in a different facility, you can, for example, do an auto. You can do a restart or shutdown of the device. This is all done remotely using this control. You have full control using the mouse on your computer. It's really easy to do, and you have it in here. Okay, so this is the remote function. You can do whatever you need with this on your oscilloscope. Let me take it out again, the math functions. And this is really cool to work with. You can also take a screenshot of what you have on the screen or record the screen directly. If you don't have, for example, HDMI capture card, you can record the screen directly in here. It's doing a recording right now. And when you stop, you have the download button to be able to download the video. And this records in 1080p, and you can download the video directly to your PC. Other than that, we have obviously the web control that I already mentioned, the take snapshot and screen record, the network status that you have everything in here. You can change the network settings. I don't remember the password, but it should be admin or just admin Rigol, something like that. Yeah, admin Rigol, it's the password. where you have the configuration. You can change this on the oscilloscope, but you are also able to change it here on this page, and you can after initialize the configuration. Okay, you have also the SCPI panel control panel, where you can send commands directly to the Rigol. For example, I asked the query of the model to the Rigol, and he answered with this string. You can put a lot of commands here. I will not go through that. And you have the security, where you can change the password, and obviously the Rigol website. Okay, and in terms of control from the PC, this is what you get. Wrap up time, and even just touching lightly some of the points I want to mention, this will be a long conclusion, but bear with me, because it will summarize everything of the experience I had while reviewing this device. I will start with the price and mentioning both series. For the entry point of the DHO900 series, we have a price of 349 euros to 499 euros, or $329 to $549 if you live in the United States. And being the main difference between the models available in the DHO series, if you go from with the 70 or 100 MHz, 2 channels or 4 channels. Talking about the DHO900 line, the prices start at 599 euros and go up to 799 euros, or $659 to $899 if you live in the US. Considering that all models on DHO900 have 4 channels and logic analyzer interface, the difference between models on the DHO900 series is based on the choice between having 125 MHz or 250 MHz of analogic bandwidth, and if you want to have the built-in arbitrary function generator or not. My model doesn't have the function generator, since I have also in the bench and already reviewed the DG922 Pro function generator, and you have the card on the corner. That is the companion function generator of this DHO900 series. I was also not able to test the logic analyzer since I didn't have here the probe, but possibly this will be a all new video where I will review the logic analyzer of this equipment. But going back to the price, is my opinion that, and according to your wallet and oscilloscope needs, obviously, both devices are non-brainer purchases. And again, this depending on the level of investment you want to do. For beginners, the DHO812 is more than enough, with a killer price. But if you want to have a bit more juice and functions like the logic analyzer and the function generator, you can't go wrong with the DHO900 series, where you will have the oscilloscope packed with all the functions with a reasonable price and the Rigol quality. Changing the focus a bit more on the features, I will start with the interface that is easy to use, but I have to confess that it took me a bit to understand all the power I had under my fingers, or more precisely, the mouse cursor. About the design, well, the design is based on the Rigol previous devices design with improvements. Sometimes I question some of Rigol decisions in terms of design, but I must say that these models from the DHO800 and 900 series have a more coherent design than some previous models. The quality is great, and I felt it in several occasions. The hard plastic in the case, the soft but accentuated button clicks, the very precise touch recognition on the screen, among other points. The user interface and experience are both good. The interface design is solid, and you kind of expect things to run on the same way in different windows, giving you a coherent and user-stable experience during the oscilloscope operation. On the channel properties window, it is very interesting the diagram that will show you all the process and switches the signal passes when you will change the different options like the coupling. Like the DG922 Pro function generator that I reviewed previously, you can also fully control it using an internet connection and a web interface. And it works great! For those that work with the server remote management, it's like using a HDMI or DRAC device to control a server. For me, as a content creator, the HDMI output is awesome, but it will be also useful to you if you want to connect an extra monitor to have a bigger display, or in that matter also a mouse or keyboard, since it is Android 7 based and support all those devices without any issue or fuss. One cool thing I noticed, and I don't know if it is the same on the DHO900 series, but with this DHO924 I received 4 350 MHz probes, even if the oscilloscope goes only up to 250 MHz. Well, for me this equipment is really nice, and that's the reason that is now the main oscilloscope of the channel for the time being. But if you need one and this one is out of your budget, go with the DHO900 series. You can't go wrong with this price versus quality ratio. But if you do have the budget for DHO900 series, I believe this oscilloscope will not let you down in terms of performance or signal analysis quality. And if you are considering to buy one, don't forget that you can use the affiliate access links on the screen or in the video description to do your purchases on AliExpress or Amazon. It will not cost you a cent more, but you'll be sponsoring the channel and helping me to produce these videos, and for that a heartfelt thank you. What will also not cost a cent more is your slap in the like button to help me spread the word. And if you are new here or just didn't subscribe yet, let me tell you that every week I receive for review in the channel new test equipment, and by subscribing it will help you to keep on the loop with all the new test equipment hitting the market. And that's all for today. I want to thank you for watching this video and for your company. I hope to see you in my next one. Until then, take care.